Today's session is openBIM Awards Program Finalists for Technology. Our finalists in this category are usBIM, Plans to BIM, presented by Tristan Garcia, ACA Software, usBIM.extender by Michelangelo Cinciulli, and then 2 by Vienna University of Technology, AR-supported teaching from Konstantin Hobart, and Q&A will be supported by Christian Schranz. This session is scheduled to last 1 hour and 30 minutes with a short Q&A for the jury at the end. And with that, I would like to hand over to Tristan for our first presentation from usBIM.
Thank you. Hello, everyone. Thanks for having me. So I will introduce you Plans to BIM, which is a technology from usBIM. We'll talk about it after. Plans to BIM is a solution, an AI solution, which allows a first smooth transition to BIM. So just a few words about usBIM. So it's an online software editor specialized in artificial intelligence for BIM. The company was founded in 2017. It comes from a deep tech from a French research organization. In French, it's Commissariat Énergie Atomique. We are 12 collaborators only for now. And we are based in Paris and in Chambéry in the French Alps. We had 21 awards so far, mainly French awards, so the international one. And we have more than 50 clients. So what we do? Our technology is to provide artificial intelligence and machine learning in order to transform 2D drawings and plans into BIM file, thanks to image recognition algorithms. And also, to strengthen our algorithms, we are able to provide a deep learning technology. So we do that for buildings, of course, but also for underground and railways networks. So, as you know, today the challenge is the modeling of plenty of existing buildings. It's too long, it's too expensive. And what we bring, what is our mission, is to simplify and accelerate modeling process and offer to our clients the most efficient preliminary steps. Okay? And of course, based on openBIM standard, which is important for us and for our customers. So let's focus on Plans to BIM. So Plans to BIM is an online solution which enables modelers, BIM modelers, to quickly transform directly their 2D drawings into BIM. So thanks to artificial intelligence, and just to know that it's patented. So how does it work? So you just go online, you have to connect the platform. You can even here try it already. You create a project. You just provide the description. So we have project A, the building. And we are going to upload a 2D drawing. It could be a PDF, a JPEG, a PDF, and a PNG format. So we work on pixels. And after that, we go to the main part, which is the modeling tool. And first of all, we have to set up the scale. Okay, we set up manually thanks to this little tool. And in order to have a number of pixels per meter. Okay, so this is quite the only the main thing to do manually, of course, for now. And after that, you can launch the algorithms. You can define some heights, like height of the doors, height of the walls. And after that, you just run the algorithms. In few seconds, you can have all the walls, doors, windows, slab, spaces, soon columns also. And after that, you can see in our 2D or 3D viewer the BIM model which were created. And the good thing also is that you can modify and correct the results directly online, which means that you have a tool to create, even from nothing, a BIM IFC file directly online. So here, for example, we can move a wall, we can suppress some elements, we can also create walls. Okay? So we can create walls, column, window, and so on. So here we just create simply a wall. Okay. This wall you can set if it's an external one or an internal one. And after that, you can change, for example, this window into a door. And you can change everything, in fact, in this tool. So it's quite easy. And you can also change the height of any element. Of course, here we are changing the height of the window. And after that, you can even change the properties of set the properties of elements. For instance, here we set the IFC material in concrete for a wall, but we can set also material of wood for this door. Okay. And after that, you can export in IFC format. Here we export directly. So we will see after that we can also export some quantity. So we launch the export. And we can see the IFC file in any kind of viewer. In this example, it's a usBIM viewer from Software. So you see that it works quite well. The concrete is well defined. Here. So this is important. It's an IFC file that we create from scratch, from A to C to B to Z. A to Z. It's work very well with any kind of software, even including Revit. And we can also assemble different floor levels. Okay. So this assembly is done manually. We just overlap the different floors. You can even add several times the same floor in order to have a whole building. And in this case, you can see that it goes very fast. You just set one of the plan as a reference plan, and after that, you overlap the other from this reference floor. Okay. For now, it's done manually, but soon it will be done automatically. Yeah. And in the same way as for one floor, you can export it into an IFC file. So you see that we are looking to have very easy things to do, even for people who are not very good at it. And here you can see in a few minutes building created. That is all the existing well. So we can also export the quantity in order to get the takeoffs. Okay. So here we launch the export the same way that we did for the IFC. And you can open the CSV file into Excel, for instance, and you have all the quantity, the volumes, the surfaces, the number of everything. Right? Very good. So the key features of Plans2BIM, it's a collaborative platform. I didn't say it, but you can work with several users from the same company. You can add image from PDF to PNG to JPEG, so it's universal. Thanks to our AI technology, it's very fast. You have a 2D and 3D viewer with an integrated simple editor tool, which could be very useful to have it everywhere. And you can assemble the stories. You have, of course, an AFC at the end, and you can also have some matrix details. So, Plans2BIM in openBIM, of course, IFC, you see, is and XML are the core of technology. we try to make interoperability very important for our clients. It's a collaborative platform, as I said. It's simple, which could be very interesting for people who don't used to work with BIM technology or with BIM software. And it's accessible from any kind of web browser. So our clients are mainly engineering offices, architects, of course, construction company, big construction company, and owner, facility, and property manager, of course. Mainly our clients are French. We hope to go to the international. Okay, we have only few people from outside France. And their market to our clients, it's management, operation, and maintenance, renovation, including thermal renovation, smart building, and even dismantling. And in a real life project, we can have this example. The thermoline company wanted to renovate with nearly zero energy building standard an old hospital, more than 3,000 square meters, and they had only old scanned plans in PDF. They want, of course, a VFC model. So you can see here such 2D drawings that we have at first, and very quickly you can have such a model. So it's very interesting for people who want to do model from existing building as soon as they have some 2D drawings. And as they say, what they like about plans to BIM is that it's simple, quick. As I said, you don't have to have a specific knowledge. It's compatible, of course, easy and fast. And this is what why the plans to BIM is very good. And as there is a lot of, as I said at first, there is a lot of existing building. We think that plans to BIM will be to make this transition seamless, open, and at least twice as fast. So thank you for building SMART Award, the jury. We think that we are an accelerator for the digitalization of existing assets, but even more, and I think it's quite important to focus on it, a trigger to encourage all building profession to move to BIM, because in this way, for example, painter, people from providing lifts, they can then really use our technology, and in particular, we managed to go to openBIM, which is important for us. So I am the CEO. Frédéric, who is here, is our technical director. So for the question and answer. And of course, we have a small team, but a good one. Without them, it would be impossible to do what we do. So thanks to them. And thanks, of course, to Building International and Building France, so too, on the jury. And we hope that together, let's make an innovative technology accessible worldwide. Merci beaucoup.
Thank you very much. We'll save Q&A for the end of this session. So now if I could invite Michelangelo up to Atlas.
Hello, everyone. Thanks for having me here for this award. Today I want to talk about usBIM.extender. It is an 100% openBIM project which works with 12 tools directly on a standard open formats, such as, for example, IFC, ECF, IDS, PSDB, and OpenCD. So, what is this project about? It is all about directly online collaboration in the cloud. In particular, this project shows how multiple operators can collaborate and work in real time on a single IC model shared in the cloud with the help of those tools that we will see here. So, usBIM.extender follows the entire BIM process, but in openBIM. So, implementation of the classes, classifications, properties, and values entered freely or via the connection with the SDT, but also geometric modification of the model, clash detection, code checking, issue tracking, and all the classical use cases. The important thing is that the openBIM standards are used natively, and that is, we use to manage and update BIM models in the cloud in real time, and not simply to share the data. As a conclusion, but I will say this as a first slide, this project will demonstrate how openBIM can increase freedom, transparency, and speed of the BIM process. So, what is the question that we would like to ask today? The question is, in BIM processes, should the openBIM be the supporting role or the starting one? And what I mean. Today, this is the situation that we have. Whenever we want to do an exchange between different software, we use the IFC format to go from software A to software B. And this means that the IFC is only used as an exchange format, so it has a supporting role. But the starting role is of the so-called nativity. Now, this approach is not bad in theory, but the problem is that in practice, the problem is that most of the software have no full support for open formats. And this means that whenever you are going to do an exchange of the data, this will be problematic because you may have data loss, difficult of interoperability with applications, and so on. And the problem is that in the end, everyone will blame IFC and not the software that are involved in the exchange. What we want to do today is to show you another point of view of the openBIM, a more closely connected approach. And we think that with our knowledge and technology, everything that we will talk about is already possible in practice. So this is basically the new role that the IFC and in general open formats could and should have. So basically, the IFC format is at the center of everything. What this means is that the various software will only give functionalities to those formats. So basically, at the center of everything, there will be the open format. So the native format will become the open format. And this, we think, is the only way to make the openBIM the starting role. So this is also in line with the technical roadmap from buildingSMART, and we completely agree with such roadmap in the sense that if we want really to reach all the benefits that the openBIM can bring to software vendors, but also and most importantly to the end users, then we have to follow this approach. So what I would like to do next is to show how we do this in practice and how with the use of those tools we can already see what this approach is all about. So the first tool that I want to talk about is usBIM OpenCD, which is a tool for connection to and from other common data environments. And this allows seamless document exchanges and data workflows. And basically, before going into practical use cases, let me explain what is the role of the common data environment, what we think a common data environment should do. We think that we should operate directly on the open formats, so IFC, IDS, BCF, but also services such as the BSD. It should do everything online, directly in the cloud, And our solution for this is called usBIM platform, so our CD, command environment. usBIM Open CD is the connection point between the different common data environments that other can use, as well as other software. And is the entry point in order to not disrupt the actual workflow that the user do daily. So this is the entry point. Also, another couple of fundamental things is that software vendors must compete on capabilities and the functionalities of the applications, and not on defining the proprietary formats that will contain the data. And also, the true value of the cloud-based solutions comes from a seamless collaboration, no need for file-based exchange, and interconnectivity. So, in the end, basically, software will provide the cloud functionalities with the browser access to the openBIM without the need to transfer files. And they will allow multiple operators to simultaneously work on the same openBIM data. These are the tools that we will see more in detail that are part of the usBIM.extender ecosystem. But I want to point out that thanks to the use of APIs, anyone can write new tools and can join this ecosystem, as well as use other similar architectures as well. So in order to show you the various tools, I will use this workflow to help me around the way that is 100% open. So what happens is that we divided this into three parts. This part is the editing part, and as I said, everything starts with the use of any kind of software that will use an RFC model, and will upload to our common data environment. Everything that will happen in the cloud, online, and everything that will happen from multiple operators that will use different tools will update the RC model in real time. So everyone will see the change that happens in real time. So for example, what kind of operation are we talking about? Refactoring of the model of the RC model in terms of spatial structure and classes, but also editing of the model in terms of its data and geometry. And when needed, a connection to the VSTP to ensure that the data in the model has high quality guaranteed by the buildingSMART methodology. So I will go into the details of those tools, and for some of them I will show you a brief use case in a short video. So usBIM Refactor in particular is the tool for refactoring and or merging different IFC models. And what it does is that it allows to reduce the geometry of one or more IFC files to create a new IFC file, also in a different version if you need to update it, by reorganizing spatial structure, IFC classes, and entity documents. And what I'm talking about is that whenever you have a model, for example, you need to upgrade to a newer version of the standard, because, for example, here everything is a building element proxy because it was not supported by the BIM modeling, then you can do two things. You can change the IFC classes and define a new spatial structure. And this is very important because different spatial structures are needed for different BIM uses and use cases. So more often than not, and this is something that we learned from the IFC 4.2 project, you want the same geometry but with its structure reorganized. So this can do exactly that. New spatial structure that the user defines, and then assign geometrical elements to the new defined spatial structure. In this case, you can decide also to change the IFC class of the geometrical objects and to add its properties, predefined types, and so on. In the end, what you will get is a new IFC file which is updated in terms of classes, if needed, in terms of IFC version, of course, if this is what is needed, but also, most importantly, with regards to its spatial structure, because as I said, different BIM models may require different spatial structures to be available. Other tools, such as usBIM classification, allows to editing the classification of the IFC model entities. And in particular, multiple users can work on the same IFC file at the same time. Then we have usBIM reclass that we have already seen in action, which allows to change IFC entities classes in order to add semantic meaning to the BIM models in the IFC file. Then, very important, usBIM editor is the tool for editing BIM models directly in IFC file. So you can edit name, properties, geometries, and so on of the entities of an IFC model and generate a new IFC model with the updates. Again, multiple users can work on the same IFC file at the same time. So let's see this in action and think about, for example, if you are in the asset management or facility management phase of the project. So you need to do a lot of small operation on the model. And of course, for example, here we are removing one flow terminal and adding another one because it is changed during the years. So of course, you want to do this directly on the open format. You cannot think about going back to the remotory who generated the data only to change this object. And there are a number of other operations as well that you want to do daily and maybe more often than one times a day. So for example, here we are deleting some object. There will be also the possibility to move objects around and so on. And this is particularly important during the facility management. And also what is important is that different operators will have the ability to do this at the same time. And in particular, when I say at the same time, what I mean is that since changes happens immediately on the IFC model, we can have, for example, user A on the left that is editing the model, and another completely different user on the right, user B, which sees what changes are happening on the model in real time, because the data is updated directly. Of course, also the contrary is true, because if on the very same object that has been just moved, the other user starts to editing the properties, changing its values, adding new ones, and so on, the changes are reflected back to the user that was moving the object as well. So all of this is possible because we are working on openBIM data that is updated in real time, regardless of the tool or of the software that is doing actually the editing of the model. Then we have usBIM BSDD, which is our way to connect to the BSDD and to enrich the data of the IFC models with this standard workflow proposed by buildingSMART that ensures data quality and information consistency. So let's see an example. So let's say that we want to connect to the editing domain, for example, and we want to classify those photovoltaics modules that we have on the roof. We have connected to the editing domain, and then we can start to do a search in this dictionary to see what is the proper classification for those elements. So we choose the correct one, which is photovoltaic module, and we are asked to fill the properties that the editing tells us that we need to put for those objects classified in. And again, everything happens in real time. So the changes from one side are reflected to all the other users in terms, in this case, of IFC classification references and property sets. And every time you update the values of the properties, for example, the other user will see the changes being reflected in real time. And more in general, BIM is a collaborative process. And thanks to the use of openBIM, you can get as much collaborative as you want, as shown in those examples. So let's continue in our workflow. We are now doing the checking part, not the editing anymore. So basically, we can use different tools and standards. For example, the new IDS standard from buildingSMART to check the content of the IFC model, but also do code checking and clash detection. Another important point is that every time you need to go back in this flow and you need to do communication inside your project team, you can use the BCF to go back at any point in time of the flow. And of course, this means that you have a look for made for improvements in order to solve the BIM issues that you will find along the way. Also, this is also very important, is that you need a way to see the differences between a different version of the files that you are producing. So usBIM IDS is the tool that will allow you to check the IFC models using the IDS standard from buildingSMART, so information delivery specification. usBIM Clash will allow you to do clash detection, so highlighting geometry conflicts in a federation of different IFC models, and usBIM BCF is what you need to discuss and solve issues in BIM models in IFC. Also, BIM Compare will allow you to catch immediately the differences between a different version of the IFC models, both in terms of geometric parts and or data. So let's see an example of the comparison of different versions. If you have followed the previous videos, we have made some editing of the model. We have classified some photovoltaic modules, but also moved some objects around. So we will take two versions of the model, and we will launch those this detection process, basically that will tell us what happened between those different models, and so we see the properties that we have added, but also the movement that we've done to the object. And when possible, for some of those operations, there are animations, for example, in this case, to show the movement that happened. Again, every time you need to collaborate and communicate to other project team members, you can always use the BCF to do the communication. And of course, for the editing part, everything that happens, every action that is done on the model is tracked down and logged in under the policy of the CD, of the commanded environment. Because remember that we are on a commanded environment. So it's not like every user can do whatever he wants on the model. So we respect the policy of the CD. So, okay, I will do the last part about the presentation, because we can also have create with a BIM render professional, photorealistic, and real-time renderings of the BIM models, and as BIM reality to navigate the models with the virtual reality. Again, everything will happen directly in the browser, and remember, this is the for example, the virtual reality part, where we can navigate the model. And since we are on a commanded environment, we can always, for example, query the object to see the attachment to each object. Or we can simply navigate the model, and we can also think about applying some of the editing to the model directly from the virtual reality. For example, moving objects, deleting objects, and so on. With regards to the rendering part, we have integrated directly online the AMD Radeon ProRender 2.0 engine, which, thanks to the use of artificial intelligence algorithms, allows basically to create photorealistic renderings with high quality and in short time. So the user has only to choose the right angle, the right spot, and the artificial intelligence will take care of the rest. So to conclude, everything that we have seen so far is an 100% workflow in openBIM, and the user acts directly on the open environment. Every tool is interchangeable with others. Others can be added as well, and at any point, the user can decide, thanks to the use of the OpenCV API, to gather its data and move to other ecosystems as well. So yeah, this is our idea and this is our concept of openBIM, and I hope that I show it to you that this everything that we have talked about is already a possibility in practice. So, as a conclusion, I will say what is our mission? Well, at Akka Software, our mission is to transform BIM to openBIM. And in particular, we want to make open standards and IFC in particular easy to use for the end users, because we really think that is this that will help to spread the adoption of openBIM and again in particular IFC format. So that's it for my presentation. Thank you very much for your attention.
Thank you.
So now we will welcome Konstantin from TwoFind for AR supported technology.
So, hello, I'm Konstantin Hilbert, and I'm here from the research unit on central building processes of the Department of Civil Engineering and Environmental Engineering at the TU Vienna. And I'm honored to be presenting to you today a project which has started as my master thesis and has evolved to the platform called AR Supported Teaching. So this is how teaching in civil engineering students has looked like a lot traditionally. Two-dimensional plans and drawings for problems in the real world which are inherently three-dimensional. And with the emergence of augmented reality as a new technology in our field, we thought that we could leverage this new technology to provide students with a more approachable way to explore building processes and problems. But during a case study, we found that current augmented reality software solutions are either part of a closed-off ecosystem, which limits the reusability and shareability in a teaching setting, or they are part of an open source library, which often require programming skills. That's why we started off building or prototyping our own solution called AR Supported Teaching, which is a platform for teachers and students to exchange to view IFC models in augmented reality and enrich them with comments and data and information which are specific to the educational process. Now, our research unit really focuses on the use and the promotion of the use of openBIM. This is why we chose IFC for our data format here. And the platform is split up into 3 applications, which I'm going to show you now. So first, there's a desktop editor, which allows importing one or multiple IFC files and allows the teacher to add different didactic elements, like animations to show the structuring or layering of a building, annotations, which can be placed along the surface of a model and include text, images or videos, as well as a button layering system where subcomponents of the model can be grouped together to control the visibility of them. Then these created teaching scenes can be opened inside the augmented reality viewer application, which is run on Android devices, either smartphones or tablets. And the created scenes can be opened and all the provided information can be explored. Additionally, we offer a live session where students and teachers can interact and share chat and voice messages, as well as live 3D pointers. And lastly, we have the link between these 2 applications, which is our web platform, which allows for group management and role management, where teaching scenes can be assigned to different user groups and new editors can be appointed, as well as a project overview where teachers can see which projects have been created in the past. Now I want to show you how this process of creating a teaching scene. We start off with a native traditional 3D BIM authoring software. We create an IFC file, which is then imported inside the editor application and enriched with the annotations and comments of the teacher, which is stored inside a JSON file. And together with this IFC, with the IFC of the JSON, these two files are pushed to that application where the access control is handled, and the augmented reality viewer then downloads these two files and displays them in the AR view. And lastly, we have this option of a live session where teachers and students come together and discuss the teaching scene and exchange text and voice messages. Now, over the last year, we have created around 40 different teaching scenes, spanning a wide variety of building problems across timber construction to concrete buildings. Now, how does openBIM come to play in our project? So IFC is really our primary import format, which allows us to be software independent. So not really, we are not really dependent on one single software manufacturer. And all teaching scenes, all created teaching scenes are stored as IFC, so we kind of future-proof our efforts. And students get to interact with openBIM and augmented reality quite early on in their studies. So they learn a key concept in the discipline alongside an emerging technology. And we think that our application is a use case and example for the multi-purpose facet of openBIM. Now, how is an IFC file handled inside our platform? We first take an existing IFC file and import it inside our editor application, which is built with Unity. We use a closed source plugin called Really to pass the geometric information and display a model. The non-geometric information is handled with an open source tool called IFC OpenShell, which outputs an XML, which we then merge together with the annotations and animations created by the teachers inside the JSON file. And both the IFC and the JSON file are pushed to the web server, where the group management is handled, and then downloaded by the augmented reality viewer application. And again, we have the live session where messages are exchanged between all three parts of the software across JSON messages in WebSockets. Now, our key outcomes are the different softwares. So there's the editor, which allows the importing of IFC data. You can select the model and then get this 3D view, where you can select sub-elements like a normal 3D viewer and get all the IFC properties, and also in hierarchy view. But we also allow you to hide specific IFC elements or properties to reduce the information density in the use of an educational setting. Then we have this layering system, which allows us to group together parts of the building on a layer and thereby create a step-by-step showcase of a model. And again, these model parts can be assigned to the layers, and you can preview the action of these layers. Lastly, we have the annotations, where the teacher can put up these flags and add titles and descriptions, as well as images and videos, and again, they can be assigned to the layer system. And this is how it looks on the viewer application. On the left side, you get the previously defined buttons. On the right side, you get the information on the selected element, which can either be an annotation or a building element. and you get the whole augmented reality experience through being able to look around in all directions and open the annotations as well via this layering system. In a more advanced scene, we allow the creation of animations. So here's an example we did for the Ministry of Sustainability and Tourism in Austria, where they were planning a new teaching center, and we did this visualization for them to show off the window front, which also integrates solar panels, as well as the timber construction underneath. We then took this platform and did a usability study with it. For the viewer application, we used the handheld augmented reality usability scale, which is a rather new usability score. And here we only scored okay because students as first-time users had issues with holding the tablet with two hands and still interacting with it, with the application. So here we would probably add a carrying case to the tablet, which allows the operation of the tablet with only one hand, which would alleviate this issue. The editor application scored a bit better with the existing usability scale. Here there were just some inconsistencies inside the user interface. But our key takeaway from this prototype was that really a large number of students thought that augmented reality can increase the learning effect. During this project, some key publications have been made. So my master's thesis on AR training application and offering tool for 3D BIM visualization in civil engineering was written, or I wrote that at the Department of Informatics together with the Department of Civil Engineering. And building upon that, our research unit published a paper called Augmented Reality in AEC Education, a case study, where the previously mentioned evaluation was done. Now, lastly, I want to highlight some key partners in our project. So there's on one side the industry partners of architectural firms and civil engineering offices who approached us to display their IFC models in augmented reality. And then, of course, educational partners, which are other research units inside our department, and the Department of Informatics and Geoinformation, as well as some local high schools where we try to bring concepts of openBIM to even younger students so they get to experience these concepts alongside augmented reality at a quite early stage. And lastly, we have an ongoing research project with the city of Vienna, where we employ augmented reality as a tool for presenting building plans in the already quite early in the stage for the public, so that they can have a look at how future buildings are planned and can offer feedback. So with this, I conclude my presentation, and again, thank you for inviting us here, and I hope I have given you an insight into our augmented reality support teaching platform.
Thank you very much. If I could ask all the presenters to come up to the front, and then we'll go to the jury for Q&A. Christian, can you hear us okay?
Yes, I can hear you. So I'm sorry for not being there, but COVID hit me just the day before I planned to fly to Montreal. So I hope you can hear me well.
We can hear you very well, thank you. Okay, are there any questions from the jury?
With the plans to BIM, we have really old buildings, and then they are created like with plan drawings, and we see that it's deviates from reality. So I've had projects where the facade was 1.5 meter wider than the plan view. So how do you cope with it? That's why I would say it's not a use case for contractors. We need some innovation.
So first of all, time to time it's work with even very old plants, even growing plants. You can have some issue of 8 or weight or whatever, but in fact this issue we are based on the data. This data should be good. If it's not, you can change.
But we know it's not good, the old buildings.
Yes, but the main part of the building is good. If you have just to move one wall or one slab and so on, you can do it easily with our technology or even in another editor, like a USB editor. But the thing is, our objective is to provide helps in order to go quick to do the modelization. We know that it's not perfect, but as soon as you have the main walls, the main windows and so on, the slab, it's go quick. After that, if you just have to shrink a bit, you can do it with our edit. But you have to do it for everything. In fact, I didn't show you, but in our software, you can do it step by step. You can first of all create the walls, correct them, and after you can detect the windows perfectly.
But how do you know what's good, right? You have to go on site and measure, and then
No,
know that it's
in fact, our technology is based on the fact that we have the data, which is the data of the client, and we assume that this data is good. And the client know that the data could be wrong.
yes.
But in this case, you have to change things, and perhaps you have to go on site.
Yeah.
But it depends. It depends what is your need also. If the need is only a quick renovation, and you need to have the surfaces and so on, it's enough. You can have some uncertainty. It depends on what is the need.
I have a question for Michelangelo. Looks like if the IFC schema changes, you have a big problem. Is that correct?
What do you mean exactly? Like the tools that we have shown are implemented regardless of the version of the schema. One of the tools, for example, the refactor one, allows you to stay up to date. Like for example, many have already had them lowered for those models, but they are maybe in IFC 2.3 older version. So you can decide to update them into a newer version of the schema. But with regards to other operations, or editing, removing objects, properties, and so on, there is no problem because the operations are then implemented based on the different versions of the
Question for the AI. Could it be that the teacher is the engineer and the student is the construction worker? So we don't need drawings and.
You mean that we shift away from the educational setting? Yeah. So that's already something that architecture bureaus approached us about, and they basically want to visualize their projects with our platform. Maybe Christian.
Yeah, we're working with some of the engineering offices together, not for the teaching purpose, but they saw the platform and say, sometimes we have a problem on the construction side, and how can we tell them easier how to solve it? And so we could use our BIM model or part of the BIM model, make an ERC, and just send it out there and can immediately impact. So this was a use case which was actually not planned in the first case when we started with Constantin, but which arrived later on, and we said that's a good use case because it's not only teaching, it's also a communication platform to the construction site.
There are no further questions. There is a question that's come through online. I don't know if we're taking. Yeah. So this was for the usBIM team. The question is it possible to export to star.rbt extensions to import it to Revit? And how can this create inclined walls, for example, or complex building?
The first part, we put the second one. The first part, we don't export directly in RBT, but you can easily open the IFC file into Revit. Normally, there is no issue, there is no dead element, everything is fine. It's important because most of our clients use Revit. So it's sure that our IFC file fit well with Revit. The second part.
The second part, how can this create inclined walls, for example, or complex building?
It's complex. For the inclined walls, it's complicated because we are working on our plans. For instance, we don't yet work on roofs like this. We just can provide some flat roofs, flat slabs. Recognition of the facade will be in the future. It's complex, right? Because, we have some R&D on it, but it's very complex. So it's not for now. We are only a sponsor.
Are there any further questions from the jury? Nope. Okay, well, we will close the session there then. Thank you very much to all of our presenters. Thank you, Christian.
Thank you. Bye-bye.
Perfect. Thank you, everyone.